Okay, a quick little recap. Last class, you learned how to do synthetic division, okay? And then we learned one application. We learned that doing the division with this number and this number is actually an xy coordinate, okay? So dividing by x minus 1 is the same thing as plugging in 1. So you have two ways to find the remainder and two ways to find the y coordinate. So we're going to continue writing down some implications or applications of synthetic division. So this one is called the factor theorem. Okay? The factor theorem. If, okay, the remainder is 0, okay, if the remainder is 0, that means that the y coordinate is 0, which means it's actually an x-intercept. Okay. All right, so if the remainder is 0, then, okay, if the remainder is 0, I think I'm going to write my sentence down here. If the remainder is 0, when f of x is divided by, all right, see that? If the remainder is 0 when we do this division, then k, comma, 0, right, x and y is an x-intercept, and x minus k is a factor. It's like a subset of what we learned last class. This time it's specific to a remainder being 0. That's it. Just means that remainder 0 means you get a factor because it divided evenly. There's nothing left. There's no remainder. All right, so here's our directions today. I'm not asking for the remainder. I'm not asking for the y coordinate. I am asking you to factor. Factor only. I'm going to give you a little bit of assistance in the factoring. Okay. So here we go. F of x equals x cubed minus 7x minus 6. And I'm going to tell you that x equals 3 is a 0. And that's what I'm going to tell you. We're going to use this factor theorem to help us with the factoring. All right, here's where the connections come in. I told you x equals 3 is a 0. That means 3 comma 0 is an x-intercept, which means should look like that on a graph. I have no idea what the rest of this looks like, but I know that's supposed to be a point on the graph. If that's a point on the graph, what is the factor supposed to be that goes with it? X minus 3 is a factor. This is like a connection to 5.1, like the graphing, zeros, factors, they all go together. I just told you x equals 3 is a 0, so you know this is an x-intercept, so you know this is the factor. Well, this is cubic, and I have 3 terms, and I'm thinking of my factoring list. GCF, pairs, quadratic, trinomial, it's cubic, it's not a quadratic. Grouping doesn't work. I'm like, I don't know how to factor this. So we're going to use our knowledge that this is a factor. So We're going to set up our synthetic division. And we're going to use the 0 or the factor as our number here. 1, 0, -7, -6. Feel free to finish filling out your division. You should get a remainder of 0. All right. Go. Okay, got a 1, a 3, a 6, I think. Something's wrong. Oh, that's a 9. That's a 9. Yeah. I'll bring another white up after lunch. Whew. Okay, so you see how I was doing that and I went a little too fast and I was like, oh, I'm not going to get a remainder of 0. That's not good because you already know the remainder is supposed to be 0. Now, here's how you're going to use this factor theorem. I'm going to highlight this outside portion right here. Because we already know that this is the result of doing the division, but the directions didn't say divide. The directions said factor. So I'm going to use that division to create the factors. Right here, you're going to start at the 3. F of x equals x minus 3 times. Okay, well, it was cubic, so now it's quadratic. See that outside L? That's actually the two things multiplied together to get the result. And I noticed that this is now a quadratic trinomial, and I can continue factoring that. So if the directions say to factor, I just used that information as a starting point. That's where I started, and then I still went back to go through my loops on my choices, and I tried to keep factoring. Okay. Second question. Factor. Okay. Given x minus 2 is a factor of f of x. Okay? And then I'm going to tell you that f of x equals okay, right here. If this is a factor, I'm just sort of going to write down my logical progression through the information, okay? So if this is the factor, then x equals 2, makes sense, is the 0. 2 comma 0 is the x-intercept, right? At some point in math, you just sort of have to take the information that's given to you and you sort of have to recall everything else that goes with it. I'm not sure which of these I'm going to use, okay? But I do need to be able to recall everything that goes with it. So if I know a factor, I know all of these things. Right? And I also know it's like actually a point on a graph, just like this. Okay, now I'm going to keep reading the question and decide which of those pieces is actually useful for me. So I'm supposed to factor it. There's 4 terms, but I don't think grouping will work because of the coefficients that I have, which means my last factoring choice is the synthetic division one. So that's where I'm actually using that 0, right? The 0 is what's going outside of that. I mean, right? Remainder 0, that's what I was expecting. I guess I could put that in here. The remainder should be 0. Makes sense. Okay, so how do I use the synthetic division to turn it into the factors? This. Okay, so f of x equals x minus 2. So it was cubic, so now it's quadratic. All right, how do you solve? You always try to factor it. Always. We just have to expand our factoring techniques. All right, can I multiply to negative 12 and add to negative 1? Yes. All right. All right, directions didn't say solve, they said factor. You guys ready for the coolest example, maybe? Okay. Factor given x equals negative 1 is a 0 with multiplicity of 2. Okay, so this is a 0, but it has a multiplicity of 2. So x to the 4th plus 2x cubed minus 6x squared minus 14x minus 7. Okay, and just like I did before I started the problem, I'm just going to write down what I know about what the problem told me. So I have this is a 0 multiplicity of 2. Multiplicity of 2. Okay. What can you tell me about the factor? You can raise your hand. What do you, yeah?
X minus 1 squared.
Almost. I do like that she said squared.
X plus 1.
x plus 1 squared is a factor because of the multiplicity of 2. Okay. What would the x-intercept be? Anyone? Yeah? Yep, -1, comma 0. I'll just tuck that on the graph. And I don't know what it would look like, but it should bounce, right? It should bounce. I just don't know much else about the graph, okay? But it should bounce at that particular spot. Okay, and I suppose the remainder should be 0. Okay. Let's try. 1, 2. Negative, right? The 0 goes out there. Okay, good. I noticed some really similar coefficients up there. 1, 1, 7, 7. That maybe the grouping could work, right? The directions say factor. Just because I started with synthetic doesn't mean I can't switch to any other method I find reasonable, okay? Now, this was 4th degree, so this would be cubic here. I think grouping could work, but that's not what I want to do. I said that that was a multiplicity of 2. That means you can divide twice. You can divide by as many things as you want. So I'm going to rewrite my numbers here. And I'm going to do my synthetic division again. Because this is a multiplicity of 2, which means you can divide by the factor twice. Notice that it's shorter, right? We're missing the last column because we already did one round of division. Oh, I got a remainder of 0 again. It's because it was a multiplicity of 2. And I'm still going to highlight the outside L, and that's still going to give me the factors. Yes, Anna.
So you can only do like the synthetic division twice when it's a multiplicity of 2?
Yes.
What if it's a multiplicity of 3?
Do it 3 times. Yeah. As many times as it will work, you can do it. Right? So if you don't get a remainder of 0, you don't want to do it because it's not a factor. Right? You only want to do this successive division if it's actually working. Okay? So if for some reason you don't get a remainder of 0, go back and check your arithmetic and make sure that it's supposed to be a factor. Okay? Yes?
So when you rewrite the second one, would it start with x squared or x cubed?
Ah, you'd have to decrease the power again. So see here, this first step would have been x cubed. When I divide again, it would be x squared. Great question. Because every time you divide, you have to reduce the degree. And notice, like, the columns are all still lining up just the way you would expect. So x plus 1, because I divided twice, and then I'm left with x squared. So there's that 0, so I'm going to skip it, and then I just get minus 7. Now, alternatively, you could certainly write that first factor with the square, but they're both correct. Okay. Okay. Part D. So we are still doing synthetic division. We are just into the applications of it. And this one is called the rational root theorem. Okay, rational root theorem. Remember that rational means ratio of integer. Okay, so we're going to write an if-then statement. If we have a polynomial, okay, p of x, f of x, whatever you want to call it. Okay, so if I have a polynomial in standard form, so that's the leading term, ax to the n plus bx to the n minus 1 dot dot dot, all the way down to the last term. Okay, so that's our polynomial standard form. Now, so if our polynomial has rational coefficients, which basically they always are going to have rational coefficients. It's just kind of how we work right now. Then, okay, where we got an if-then statement. Logic is my favorite part of geometry. If then all possible rational roots. Okay, so this is a theorem about listing all the possible roots or answers or zeros, whatever you want to call them. All possible rational roots are. Oh, so my theorem is giving me a way to write down all the potential answers. Okay, this is the PQ list. So you saw the PQ list in some of the homeworks. This is the PQ part. Okay, PQ. There's like 2 steps here. Equals factors of the last number, or the constant. Okay, that's the D, right? The last number. Okay, it's the last number over factors of the first number, or the leading coefficient. That is the A. It's just the A. Okay, factors of the last number over factors of the first number. Now the part I always forget is which one goes on the top. Right, without memorizing it, like which one goes on the top. So we're going to write little thinking cloud.
What does the last one say on the top?
Constant. The constant term, the one without the variable. Yeah. I print cursive combos sometimes. There you go.
What is LC?
Leading coefficient. Yeah. Lead coefficient. There you go. Right, here's my thinking bubble. Y equals AX plus D. Right, degree 1, the A is the first number, the D is the last number. I want to solve this for 0. X equals. So what do you do first? First, you add or subtract the last number. What do you do? Then you divide by the first number. It's the last one over the first one. If you're trying to remember which one goes where, break it down to the simplest linear factor. It's the last number, then the one in front of the x is what you're dividing by. Right? It's the one in front of the x that you are dividing by. Okay, so now I actually have to like show you how to use this. Okay? If I have a polynomial, then I can list out all the possible answers. All right, example. Y equals 3x squared minus x minus 2. List all possible rational roots. It doesn't say solve, it says list. So that's all I'm going to do. Last number, first number. Okay, so I'm going to start by just writing P over Q. Last number, first number. The negative, I'm going to explain why the negative is not included, okay? So I'm going to start by writing 2 here. And I'm going to write out the factors of 2, which is 1 and 2. So I'm going to write 1, comma 2. There's actually a couple steps to how we get to the final list, right? Factors of the last number over factors of the first number. So that's just 1 and 3. Now, these could be all opposite signs, right? This could be positive, negative, negative, positive, positive, positive. All right, so we've got all sorts of pluses and minuses here, okay? As I write down my final list, I have to pair up all the possibilities. So I'm going to start with 1. 1 over 1, 1 over 3. 1 over 1, 1 over 3. And then I'm going to move to the next number on the top, and I'm going to pair up everything that way. Okay, I'm going to start with 2. 2 over 1, 2 over 3. That is all the possibilities, because you have to do all the combinations. All right. And then when I actually box my answer, I'm going to put plus or minus with every number because I could have all the different signs. Plus or minus 1/3, plus or minus 2, plus or minus 2/3. So there's actually 8 possible potential answers. This didn't say find them, it just said find the possibles. Okay. Try it yourself. Y equals okay. X to the 4th plus 2x cubed minus 6x squared minus 14x minus 7. Okay, same thing. List all possible rational roots. Okay, so that's the PQ. Okay, make your PQ list. Question. Okay, last number, first number. Okay. Last number, first number. Okay, so it's just 1 and 7 and 1. Okay, then I got to pair it all up.
Wait, how did you get 1, 7, and 1?
This one,
Oh, I did not write the -7.
you don't have to write it's not -7. The negative's not actually important. It's the last number over the first number, but it's factors of the last number, which is 1 and 7, and factors of the first number, which is just 1. And then I pair them up. And then I write my final list. Okay. Like, great, but like, what's the point of making a list of numbers if only some of them might be answers? This is where your Desmos comes in. So I'm going to pop up a quick Desmos graph. Desmos graphing calculator. See you later. Okay, hold on, it's coming. And I am going to graph, whoop. I'm going to scooch this up, and I'm going to graph, like too bright today. Hold on. There we go, that's better. Okay, here we go. Y equals x power 4 plus 2x power 3 minus 6x power 2 minus 14x minus 7. Okay. Based on this picture, which answers might you think are actually solutions? -1? Based on this graph, which one of these possible solutions actually looks like it might work? Just -1. Wait, double. Check out that bounce. Guys, it's all coming together. I know a bounce on the graph means 2 solutions. This list is giving me the potential solutions. Okay? So you are going to put this PQ list together with the Desmos graph, and you are going to circle the potential ones that you think are actually going to work. Now, I'm going to scooch up, and I'm going to graph this other one just so that you can see it. Okay, so we get 3x squared minus x minus 2. Okay, and I'm going to zoom in just a little bit here. All right, based on this picture, which solutions do we think are working? Okay, so I see +1. Oh, okay. Nice thing about Desmos, -2/3. Now look, my only fraction choice is 1/3 and 2/3. So I'm pretty sure that number looks closer to 2/3. I'm just guessing which one I think is going to work. So that one is -2/3. So based on the picture, you are going to narrow your guesses down to what you think will actually work. Okay, that brings us to our final two examples, where instead of just listing the PQs, we're going to use the PQs to solve for all zeros. Okay, so we learned how to factor. Great. Now I've learned how to identify those factors with the PQ list. Now we're going to go all the way to the solutions. Here we go. You can do it. This is so exciting for me. You can laugh at me, it's okay. Solve for all zeros.
How much of a page you need
Took me a whole page. It's because I write big, guys. That's what it's gonna look like.
Oh my gosh.
Yeah, you'll probably want like that much space. You could easily do it like in two little columns, maybe like six rows. Okay. Y equals 2x to the 5th, 15x to the 4th, 41x cubed, woo, 49x squared, 24x plus 4. First up, I'm like, you want me to factor? You're like, yeah, I don't think so. Right? Like, there's a lot of terms there. So, but if you're trying to factor and all of your original techniques aren't working, then do your PQ/synthetic division. Okay? So you're going to make a PQ list and a little sketch from Desmos to narrow your choices down. Okay, last number, first number. Right? Yes, you can use Desmos. Okay? Last number, first number, and then a little Desmos sketch to help narrow your choices. Okay, I'll start graphing it so that you can look at it. You make your PQ list while I pull up the graph. Okay. Woo. Okay, so zoomed in. Right, that's just a picture. Right, from Desmos, which is fine. -1, -2. So it bounces. Comes up. Okay, so it's not a great replica that I drew here. All right. 4 and 2. All right, so the factors of 4 are 1 and 4, 2 and 2. So 1, 2, and 4. Those are my factors of the last term. My factors of the first term are 1 and 2. So now I need to pair them all up. 1 over 1, 1 over 2, 2 over 1, 2 over 2, 4 over 1, 4 over 2. All right. Reduce 1, 1/2, 2. Okay, I know that 2 over 2 reduces to 1. I'm not going to rewrite it. 4. And 4 over 2 reduces to 2. So I'm not going to rewrite it. This is my list. I have 8 potential PQ numbers. Okay, guys, based on the graph, you need to circle what you think is going to work. Yes.
I was just gonna say it.
Which one?
I was gonna say it.
Yeah, go for it.
I got negative 2 and it's a double to the boundary.
Yes, -2 double. Love it. That's right here. That's for the double. Okay, based off of that picture, we only have one fraction. Guys, the only fraction up here is 1/2. So if I have to have an answer right here, I'm going to go with -1/2 as the other potential. Okay, I've done my PQ list. I've looked at my graph. I've put my knowledge together. I think I have 3 zeros. Well, if I give you 3 zeros, you can divide them out to help you factor. And that's what we're going to do. Okay. This was to help find zeros to factor. That's all we were doing. That giant PQ thing, that was to help us find the zeros to factor. All right, so let's set it up. 2. Whew. Okay, 15, 41, 49, 24, and 4. All right, I'm going to start with the one that looked more sure to me, the integer. That's where I'm going to start. Oh. Okay, fantastic. I was expecting a remainder of 0. It also appears to be a double. So I'm going to do it again, right? It looks like that's a double 0 for the bounce. So I'm going to do it again.
Wait, how do you know if you do it again?
Okay, see right here how it's a bounce?
Oh, okay, so you do need the decimals for that.
Yes. Well, I do need the Desmos because I don't want to try all 8 of these. I really only want to try the ones that are supposed to work.
So like on the test when we have decimals?
Yes, you will have a picture of the graph to work with.
Oh. And
Yeah.
Will something this complicated be on the test?
Possibly. Okay. You can do it. Will you have access to Desmos while you're doing it? Yes.
Oh, okay.
So you will have the labeled scaled picture to match up your zeros.
Okay, that's helpful. I thought you were just setting us in blind.
No, no, no. You're going to get some assistance there. Woo! All right, look at that. Double 0. Double 0. Okay, I have one more. I have the -1/2. I went with my most sure thing first. Okay, the half. -1/2. And I'm like, please work. Notice your synthetic division is getting smaller each time because we've already done that division up there, right? It should shrink because it's like successive division. All right. Look at all that fancy factoring you did. All right, so y equals x plus 2 squared, because it's a multiplicity of 2, x plus 1/2. All right, so now I have to think. I started with a 5th degree, and I divided 3 times. So if you have a 5, you've got a degree of 2 left, because you have to decrease it 3 times. So this would have gone to a 4th, 3rd, so that means that this is squared. All right. Whew. All right, guys, I know. Don't forget, you're actually solving for all zeros. Yes.
So why do we only use -1/2 on the last one?
Where'd you want to use it?
I don't know. I just
You can actually do them in any order you want. I was more confident about my -2 because like that integer was really easy to see on the graph. So I started with my most confident 0. That's my only reason. You could do them in any order you want.
So could you not use -2 for all of them?
What do you say that again?
Could you not use -2 for all of them?
-2 is not a triple. -2 only bounces on the graph. This is -2. This is a bounce. That means it only repeats twice. Here's my other 0. They're both linear. They're both a repetition of 1. Okay. You're almost there, guys. You're almost there. X equals -2, -2 minus 1/2, clearly. And this factor equal to 0. Right? You're solving. Guys, the question said solve. You just did all that fancy work to factor it, but you are solving. I am going to divide everything by 2 first because I see that. And then I'm looking at it, I'm like, I can't factor that, so I guess I'll just quadratic formula. Opposite b plus or minus b squared minus 4ac all over 2a. All right. Oh, that doesn't even, there's like no simplifying there. That's nice. There it is. How many answers? 5 real answers because it was a degree 5. Okay. I'll let you kind of process for a minute. It's shorter, actually. Okay, so I'm going to zoom out so we can take a big picture here on what we did. Whew. Okay, so let's look for the understanding here. I wanted to find all the zeros, so I started to factor. My regular factoring techniques failed me, so I used the graph and the PQ list to narrow my choices, and I used synthetic division to factor it. Once I got all of my factors, then I set each factor to 0. Okay? All of this work up here was just a fancy way of factoring. Hey, did I really have to write a PQ list? Not if you've got a really amazing graph. You can just pick the numbers off of your graph. Well, I saw a -2. Boom, I could do that twice. 1, 2. Right? I'm just showing you how to match up the PQ list because it does have some applications. But could you just use the graph? Yes, you could just use the graph. Okay, we're going to finish up with the last example, and then hopefully I will show you what's in your homework. All right. We have to divide synthetically twice. So if you try to do it like in half of it with your synthetic division and then put the other half.
I can just do it on a page. I was gonna say, you do synthetic division and that, and you're solving over there, you can probably make it work.
Depends. Yes. No, not when it's x equals no. Okay. All right. So I see x equals 3. I got that part from my graph. It's this part right here that I'm a little concerned with. So you start trying to write that PQ list. I'm going to actually pop up the graph in Desmos. (36x power 4) minus 114x power 3. Okay, so last, as this one gets a little tricky, see if we can do it. Last and first. Okay, so 3 is not that bad. It's just 1 and 3. Okay, 36 actually has a pretty long list. Okay, so as you write down your factors of 36, 1, 2, 3, 4, 6, 9, 12, 18, 36. All right. Now, this is a pretty long list. So as I start writing this, I'm going to reduce as I go. Plus or minus 1. Plus or minus 1/2. 1/3. 1/4. 1/6. 1/9. 1/12. Okay. 1/18. 1/36. That is a lot of fractions to look at. Now I'm going to do the 3. Plus or minus 3. Plus or minus 3/2. Wait, hold on. Watch this. 3/3 reduces. Don't write it. 3/4. 3/6 reduces. 3/9 reduces. 3/12 reduces. 3/18 reduces. 3/36 reduces. So that's actually the whole list. And yes, that is a very long list. So as I'm looking at my graph, guys, I know I have an answer between one of these fractions, except I don't know which fraction. So as you get your Desmos, look at this. Oh, you need the one that's close to 0.16. You need a number close to 0.16. So what I suggest doing is checking out what your numbers are. Okay, 1/2, no. 1/3, nope. 1/4, nope. 1/6, yes. That means 1/6 is my number. Okay, so 1/6 and 3. Those are my two numbers. Right, guys, you have Desmos, you have some arithmetic. Narrow your choices down by using both of it. because there's 5 minutes, I'm just going to start doing the work. I'm going to do my division with the 2 zeros I just found. You can start, it doesn't matter which one you do first. I like to do integers first, but it doesn't matter. $90. Thank you. -6. Whew. Okay, got myself a 0. Am I extra lazy and I'm not even going to rewrite my numbers?
Oh, that's what I've been doing.
Oh yeah, totally. All right, I'm just going to rewrite my numbers. Just like this. Just keep bringing it down. Woo! Okay, that's it. Those are all the zeros I found from my graph. So I'm just going to turn those things into my factors so that I can actually solve. All right, I do see that there's a common 6 in this factor here, so I'm just going to take that out just because I noticed that that was possible. Okay, and x equals 3 and 1/6, which we kind of already knew. All right. Oh, this factor equal to 0. Okay, I isolate. Square root. I know. Plus or minus. Okay, guys. What is the square root of -1? I. Okay. Now, you can either leave it like this, or you can write it like this. I will take either at this moment. One of them is rationalized, one of them is not. Whew. Okay, guys. That was a lot.